Here on this part, we have Euler diagrams and syllogistic arguments. An Euler diagram is a Venn diagram that describes the syllogistic argument. Syllogistic argument or syllogism are arguments of one of the following forms. The first one is all or. Here is example for this part. All dogs are hairy. The second one is no or. Example is no doctor is short. Third one is some are. So here we have all, no, some. An example, some apples are green. And finally, here we have some are not. Example, some apples are not green. So these are what we are going to use in this section. Here on this part, it's asking to draw a Venn diagram for each of these arguments that we have on top. Since we have all, this means, for example, using circle for each one of these, using one circle for dogs, the other one is for hairy, I should have all members that I have inside this part for dogs. I should have all these members inside the other circle, which is for hairy. First, I'm going to draw dogs. This is one circle. And all of these members here inside this circle, these should be inside the other one. And this green part, that is for hairy. So that was for the first one. Now the second is no doctor is short. Again, I'm going to start with the first one is doctor. Since we have no, that means there is no intersection. No intersection between doctor and short. Now, the other one, drawing like this, I don't want to have intersection between these two circles because of having no. But this is what we have for the second part. The third one is some apples are green. Again, I'm going to draw this part first. So here we have apples. For this part, we have some. This means there is intersection between apples and green. So when we try to draw the second part for green here, we should know that there is some members that are in common. I'm drawing this way. This is green, and here is intersection part. So some apples are green. And finally, some apples are not. We have intersection, but here it says are not green. Again, I'm going to start with the first one, apples. We have some. But the point is, here we have are not green. So some of these apples are not green. Use either diagram to determine whether these is valid or invalid. All Jeffs are bills. The second statement, no bills are dogs, and conclusion, no Jeffs are dogs. This is same as what we did in 3.5. We having P1, P2, premise 1, premise 2, and finally conclusion. But we're not going to use symbolic form. So I'm going to draw this one first. All Jeffs are bills, starting with this part. So that is Jeffs, and all these members, we should have them inside the other one. So this was the first one. Now the second statement, we have no bills or dogs. We already have bills here in green color. Since we have no, that means there's no intersection. So none of these members that we have inside the green part, none of those are inside this part. That is same for Jeffs, because we have all these members here inside green part. We're not going to have any members from Jeffs or from bills inside the third one for dogs. Now we want to see if this part conclusion, is this correct based on what we draw here? No Jeffs are dogs. So based on what we have here, reading our conclusion, We shouldn't have any members from Jeffs inside docs. So I'm going to write this part. What we have to do here in this case, we have to ask, since it's asking if this is valid or invalid. Does this Venn diagram imply that our conclusion, no Jeffs or docs? Our answer was yes. And that was because Jeffs and dogs have nothing in common. You can write that way, nothing in common, or you can write no intersection between these two. Because of answering yes, this argument is valid. Part B, all planets are satellites. Picard is satellite. Conclusion, Picard is a planet. The first one, all planets. So first I'm going to draw this part, planets. And all of these members are inside the second part, which is satellite. Now, second statement, Picard is satellite. I'm going to read the conclusion also. I'm going to see what we have here. Picard is planet. Okay, so Picard is satellite. I can have that satellite here on this part, that Picard here in this part, or I can have that part here inside planet and satellite. It doesn't say that it's not inside planet here on the second part. It's just saying Picard is satellite. So I can have either here on this part or on this part. Conclusion, Picard is planet. This one, if we have this one, the answer is true. The answer is correct for the conclusion. But what if we had our Picard here inside satellite, but not inside planet? So this means conclusion is not correct. This one is Picard. You can have that on that part or here. So Picard could be satellite or a planet. Here again on this part, we have to ask, Does this Venn diagram apply our conclusion? Picard is a planet? No, because I may have that part here inside satellite only, not in planet. Because Picard could be outside the planet. Meaning this part is invalid. Part C, some mushrooms are poisonous. Moral is mushroom. Conclusion, moral is poisonous. So in this part we have some, meaning we have some members from mushrooms that are inside poisonous. Again, I'm going to draw mushrooms first. And then we have poisonous, but because of having some, we have intersection between these two circles. So this part is some intersection between these two. Now the second part, moral is mushroom. We have this circle for moral here inside the red part. Here it says moral is a mushroom. I can have that part here on this side. I can have here on this part. So I can have this moral here outside of the intersection part, or inside the intersection between poisonous and mushroom. Now conclusion, moral is poisonous. If I had moral here inside only, the intersection part, I can say the answer is correct. Moral is poisonous in this case. But what if we had that outside of intersection part and was here? If I had this here, that means the conclusion is not correct. Since we have two ways to draw moral, we cannot say that conclusion is correct. Our question is, does the Venn diagram imply that moral is poisonous? So our answer is no. The reason is moral may not be in the intersection part. all dolphins are mammals. All mammals are vertebrate. Conclusion, all dolphins are vertebrates. Starting with the first one. And here we have the second circle. So all of these members here inside dolphins, these are inside another circle. So that was the first one. Now here on this part, we have all mammals are vertebrates. So this is another one. Because here again, we had all. So we should have all members inside the green part. We should have all those here inside vertebrates, which is in purple color. Now finally, what the conclusion is, all dolphins are vertebrates. Our answer for this one was yes. Because all members that we have inside dolphin are inside vertebrates. So this one is valid.